Hello everyone, welcome to this video where we're going to look at how we can model isolated footings or spread footings with eccentric pedestals. I'm going to start off just by drawing a regular isolated footing using the default parameters here. So we've got our default pad size, 4,000 millimeters by 2,500 millimeters wide and 500 millimeters deep. I've got my pedestal. I'm just going to use a default pedestal and I'm just going to place this somewhere in my model. As you can see, the pedestal is by default concentric to the pad. So I have one foundation in there. And I'm going to repeat this process here, but I'm going to do things a little bit differently. So when I still use the isolated footing tool, it's going to assume that I want to continue using the same pad, which I will in this case, but if we wanted to create a new pad, we could always click on the new option and redefine the parameters. You'll notice here that they're currently read-only because it's using that pad that's already existing in my model for future usage, but I can always replace it with something else. But I do want to draw our attention here to this offset field here. And in this field, we can actually define an offset. And I will need to create a new pad to do this. So I'm just going to click on the new option. And basically it just exposes all of these different parameters that we had previously had set to read only. I'm not going to make any changes other than the fact that I do want to change my offset. So I can change the offset relative to the local coordinate system, specifically relative to the center of the pad. So if I want to change a pad offset here, I'll say 1,000 millimeters. And you'll notice here, now I've got that pad eccentric to my pedestal. So the pedestal kind of forms the basis for our local coordinate system of our foundation. And in this case here, it's also allowing us to offset the pad relative to that pedestal location. And we can offset it relative to the center of the pad or relative to the edge of the pad. And we can do the same thing in the y-axis. Let me just place this foundation down here. And I'm going to apply equal loads to each one of these. I'll just say a negative 500 kilonewton load to each. And I'm going to go ahead and run an analysis and a code check. And as you can imagine, with no other loads, including the fact that I'm actually ignoring self-weight, which is an unrealistic scenario, but you can see here that we have a high loss of contact utilization. And our results will naturally vary. So that's what's failing right now is the loss of contact, where a large portion of our structure on the eccentric pad is actually coming off contact with the ground. I can look at the soil bearing pressure and I can see that as well here. I should note that that loss of contact is using a default capacity, and it's basically a percentage of the area of the pad that is having zero pressure. And in this case here, we can see that where this gray area occurs, there is zero pressure on the soil underneath. So that part is actually lifting up. So that's a quick kind of tutorial into how to do that. You can also modify these after the fact as well. So if I wanted to click on this, I can right click, go to define pad pile cap, and I can modify this offset. So I can go maybe 200 millimeters instead of 500, click apply, and you can see here it's moved that over quite a bit. We'll naturally have to reanalyze, but it gives us the ability to make those changes on the fly.